Hello, friend. Good morning, good afternoon, or good evening. From I don't know from which time zone you were seeing this, but welcome to another session of Quant. If you are first time visiting this video, I am Orko. I primarily help here for CAT in MATSNAP AFT kind of exams from the quant side. So what we do here is we take one quant topic, talk about it in depth as a fundament in the fundamental session, and then we do two follow-up sessions on that topic. While on the first session of that, we do foundational or conceptual level problem that completely clears out all your conceptual doubts or the techniques or the concepts that you have learned in the first foundational session of that topic. It clears out all that. So we do solve problem in order to focus on clear your conceptual clarity or doubts that you possibly have from the first session, or cement your understanding of that topic in the next session. Or at the problem session 2, we do talk about in depth on advanced level problems or probably tough level problems or complex tricky problem, which will be very relevant for your CAT snap exams. But having said that, what we do in the problem session 1 also has a very high likelihood of coming in exams like CAT and MAT snap IFT. So and do go through this, and like I said in always every session, that don't try to see the problem and continue seeing the video with the solution that I'm giving. If you see the problem, put down your pen and paper, or use your pen and paper. Do try out the problem for 2 to 3 minutes if it is happening. If you can able to solve the problem, solve it, come back and see the video whether you have done it right or whether there is a better approach to do it. If you are not able to solve the problem after 2 minutes, come back and continue the video and see the solution. But at least try by yourself first, use your mind first, see what you were thinking, then come back and see what I was thinking, or is there anything needed to change in your thinking, and apply that in the next problem. So that's how you will going to learn this. So without further ado, we will start. So indecision search as a topic, as a fundamental concept, we have already covered in the previous session. I'll put the session in the description box or somewhere in my button. You possibly, and I highly suggest you should see that video first before you seeing this video, because this is going to apply some of the concepts or some of the type of problem that we have spoken about in the previous session. Okay, let's start with the first problem. So let's see what is given. 3125 whole to the power 5. 3125 whole to the power 5 into 625 to the power minus 4 into 125 to the power 125 minus 5 divided by 5 to the power 6. So this is given. So 3125, if we know 3125 is nothing but 625 into 5. 625 is 5 to the power 4 into 5. So 5 to the power 4 because it's 25 squared. So these are the few squares or cubes you need to remember. Please refer to the speed math session that we have covered, and we have given you a list of things that you should be absolutely memorize and has to be on top of your mind. So do go through that list, take a printout of that list, stick it where you study, and go through that at least up 2 to 3 minutes or maximum 5 minutes you need before you study each day, and do it for 3 weeks. It should be absolutely familiarized with you. So like the way you remember your family members, the moment you see them, you recognize. Similarly, the moment you recognize these numbers, 625, 729, which is 27 square. So these things should be, so the moment you see the number, the moment you know which square or which cube is this number. So that should be the level of familiarization that should have been done for that list that I have given in speed math session. I'll give that link in the description box. You can possibly check that session out. So 3125 to the power 5, which is 5 to the power 5. Sorry, 5 to the power 5 to the power 5 to 625 whole to the power 4. So that means 5 to the power 4 to the power minus 4. This is 5 cube whole to the power 125 divided by 5 to the power 6. And this is 5 to the power 125. sorry, not 125, 5 to the power 25 into 5 to the power minus 16, 4 to minus 4 into 5 to the power 375 divided by 5 to the power 6. So multiplication means addition. So 5 to the power, so this is 25 plus minus 16 plus 375. Since the last one is a division, so that will be minus 6. So this is given. So 375 plus 25 is 400 and 16 minus 6 is 22. So 5 to the power 400 minus 22. The answer is 5 to the power 378. Right? So this is the first problem. If you have any doubt, please drop a comment in the description box. Or if you need more clarity on this topic, you can drop me a mail also in the mail ID given. Again, the mail ID will be, you will get in the description box. So the next problem we talk about A, B, C, and X are non-zero real numbers. A plus B plus C is 0. So this is a very good problem. So we need to see this problem very carefully and see the step by step that we are going through. So this is first is written 1 by x to the power a plus b plus x to the power b plus 1 plus 1 by x to the power b plus c plus 1 by x to the power c plus a, so x to the power a plus 1. So if we have to do this, see this, there are multiple ways to solve this problem, but I'm trying to do certain steps so that I will be able to utilize this a plus b plus c equal to 0. So if something is 1, I can write it as x to the power 0, or which is I can actually write it as x to the power a plus b plus c. I'll not, okay, if it's not visible, let me just write this. So this is x to the power a plus b plus c. So I will not replace all the ones with this, but I will replace some one with this and possibly try to make a relation between these two, because as it is given, you can't use a plus b plus c right away. So let's see. So x to the power a plus b, x to the power b plus 1 plus, let's see, I'll replace this one. So x to the power b plus c, x to the power c, x to the power a plus b plus c. Right? So that is done. And in the last one, this is x to the power c plus a. Now I know a plus b plus c equal to 0. So c plus a is equal to minus b. So x to the power minus b, x to the power a plus 1. So again, the first one remain unchanged because I'm trying to pivot around the first one. So let's see. So x to the power a plus b, x to the power b plus 1 for the first one. The second one, if I multiply and just c plus a, and then I can also write your a plus b is equal to minus c, right? So I'm just trying to see if we write x to the power minus c, if I just multiply the entire thing with x to the power minus c. So basically I'm trying to get away with c so that everything comes at a and b. So with the, since I'm using the first one unchanged, so I'm trying to do the other two towards that. So if I remove x to the power c, if I divide, so x to the power c, if you multiply with x to the power b plus c, x to the power c multiplied on numerator and denominator for the second term. So numerator multiplied with 1 becomes x to the power minus c. Denominator, the first term will become x to the power b. The second term will become 1. X to the power minus c into x to the power c is 1. And then the last term will become x to the power a plus b, right? Because if I multiply x to the power a plus b plus c with x to the power minus c, c will get cancelled. So I have multiplied, in this case, the second term in numerator x to the power minus c, same with denominator x to the power minus c. So first term in the denominator x to the power minus c, if you multiply with x to the power b plus c, you will get x to the power b only. Second term x to the power c plus minus c will become 0 and become 1. Third term x to the power a plus b plus c, if you multiply with x to the power minus c, it will become x to the power a plus b, right? And this one, I have 1 by x to the power b plus x to the power a plus 1, right? I hope this is visible. Okay, now this again I am keeping it unchanged, x to the power a plus b plus x to the power b plus 1 plus x to the power c. I can write it as x to the power a plus b, right? And then I have x to the power a plus b. See, this has become the same as the first one. The denominator of the first one and the second one are same. So this will also become like this. So x to the power b here. If I just simplify, so then this becomes 1 plus x to the power a plus b plus x to the power b. So if you just do this denominator, simplify this denominator, it will become like this. So now if you see, your denominator is same for all the three and your numerator has all the three terms separately given. So if I do that, your whole denominator will be still around x to the power a plus b plus x to the power b plus 1, and your numerator will have same 1 plus x to the power a plus b plus x to the power b. Both are same, so it will give you 1. So 1 is the answer. Again, go step by step. There is no one method to it. I tried to pivot around the first one. You can try to pivot around the last one. In that case, you have to eliminate b because the last one does not have b. First term did not have c. So I tried to eliminate c by creating certain scenarios so that it will become, if I'm pivoting around the first one, the other two essentially falls in space and give the similar things that are needed for the first one. So that's what I try to do, some here and there. Obviously, there is no set method to it. You can take any one of the term, like I take the first one, you can take the third one and try to do the same approach by try to see eliminates b from the first two and get everything around the third one. So anything is possible. So not absolutely this is only the way you should go, but this is one way you can solve it. Okay, let's go to the next problem. It says 125 to the power 3x plus 2. So 125 to the power 3x plus 2 should be equal to 3125 to the power 3x minus 12. 3125 to the power 3x minus 12. So 125 is what? 125 is your 5 cube. So can I say 5 to the power 3 into 3x? So 3x plus 2 is equal to 3125. We know 5 to the power 5. So 5 to the power 5 into 3x minus 12. So then can I write, since both the bases are same, 3 into 3x plus 2 is equal to 5 into 3x minus 12. So then this becomes 9x plus 6 is equal to 15x minus 60. So this is given. So if I take the x on the one side, it becomes 6x is equal to 66, or x becomes 11, right? So x becomes 11. Straightforward step-by-step approach, just making the base same and you can solve the problem from there. Moving to the next one. There are two types. If you recall what we talked in the last session, if the powers are integer, you have to find out. So these are two different problems. This is, let's say, problem 1. This is problem 2. So the first one, we have to find out which is the greater one. Which is the greater one in both the cases. So first one, if you see, typically what we said, if the powers are in integer, you have to find out the HCF and divide both the integer with their HCF. So 30 and 40. So I say HCF of 30 and 40 is 10, right? So if I divide this, so then it becomes 20 to the power 30 becomes 20 cube and 8 to the power 40 becomes 8 to the power 4. Since I'm dividing both the term with the same value, uh, it won't change the nature of the term that is given, or it won't change the value. So out of this 20 cube and 8 to the power 4, whichever is the higher, whichever is the greater, that will happen same if you multiply both the, that will remain same if you multiply both the power with 10. So you will give 20 to the power 30 and 8 to the power 40 will have the same relation of 20 cube and 8 to the power 4, because I'm just dividing both of the power with the same number. Again, in depth we have covered in the concept session, which is the last session that we did. And if you have seen that very well, you can understand this. But if you have not seen that, please refer to that video first, where we have exactly said how to do this kind of a thing. But yeah, the at a lowest level, it should understand that if the powers are in integer like 30 and 40, and you are doing a comparison, you should, more than two numbers can also be there. If you are doing a comparison, take all the powers HCF, and then whatever the value of HCF, divide all the power with that, so that your equation becomes simplified. So I know 20 cube 8 to the power 4 is somewhere around 5112 into 8, right? 8 to the power 4. But 20 cube is 400 into 20. 20 square is 400. So I can easily say this is somewhere around 8,000. This is 96 and 4096. Obviously, this 20 cube is much higher than 8 to the power 4, which was also visible from the number itself, but I still solve. 20 cube is greater than 8 to the power 4, hence 20 to the power 30 is greater than 8 to the power 40. Okay? That's the first one. The second one, if you have fractions, the idea is to do LCM of the denominators and multiply the LCM in both the cases in the power. So here I will do LCM of 5 and 4 because the fractions denominators are 5 and 4. So this is 20. Again, one topic we have covered in depth in the concept session. So then I will do 7 to the power 1 by 5 into 20. And similarly, I'll do 6 to the power 1 by 4 into 20. So this is what we'll do. So that means this gives us 7 to the power 4 and this gives us 6 to the power 5. So 7 to the power 4 is what? 7 cube is 343 into 7. 6 to the power 5. So 6 square is 36. 6 cube is 216. So 216 into 36. Right? So this is given. So if you just calculate, obviously it looks like this is a very high number. 7 to the power 4 is 216 into 36 is much higher than 7343 into 7, right? So obviously this is a, we don't need to calculate, but if you calculate also, this is a higher number. So 7 to the power 4 is less than 6 to the power 5. So 6 to the power 5 is the higher number, or not 6 to the power 5, I will say 6 to the power 1 by 4 is the higher number. Okay. Let's move on. Okay. They said, what are the values of x and y that satisfies this equation? Okay, let's see. They said 2 to the power x, 9 to the power y is 648. So basically what you have to do is you have to break 648 into the power of 2 and 9. Okay. So I'll quickly show you. If I do 640, just a minute. If I do 648, the breakup of 648, now you will do with, start with 2. So you will get 34, 342, and then you will get 171, which is 3. So then you will get something around 57, then you will 3. So just a minute. Okay. No, sorry, my bad. So this is 344. This is 344. Not sorry, not 3. this is 324, sorry, in fact 324. So 3 you will get 162, and then again you will do with 2, you will get 81, then you will do with 9, you will get 9 here. So I can say this 648 is nothing but 2 cube into 9 square, right? 2 cube into 9 square, 2 to the power x into 9 to the power y. So this is 2 cube into 9 square. And from the next one, so from here I can say x has to be 3 and y has to be 2, right? Let's see what is, can this satisfy with the other one. I don't need necessarily to solve the other one. So from one, I'll just validate. So this is 4, other one becomes 4 cube and 27 square if we consider these values of x and y. So 4 cube is 64, 27 square is 729. If you multiply these two, you will get 46656. So this is your answer. Okay. So you don't need two equations necessarily, but yeah, you can still solve the problem. Okay. 9 to the power 5x to the power minus 7. 9 to the power 5x. 9 to the power 5x minus 7 is equal to 9 cube, then 1, 3, 4, 5. Remember, this is one type of problem we solved in the previous session where we told you whenever this power to the power is given, always start from the top, right? So this means this is 9 cube to the power 1 to the power cube. This is 4 to the power 5, right? So this is 4 to the power 5. 4 to the power 5 is how much? 4 cube is 64. 4 to the power 4 is 256. So this is 3 to the power 1024. Similarly, you have to do that. But if you see here, this is 1 to the power something. So there is a 1. 1 to the power, anything you do, it will become 1. So 9 to the power cube to the power 1, it will become. That means it is nothing but 9 cube. So can I say 5x minus 7 is nothing but 3, and 5x becomes 10 and x becomes 2. So it looks like a very complex problem, but if you see, since there is a power of 1 is given, obviously anything you keep on 1, it will become 1. So the entire calculation simplifies to 1. So 9 to the power 3 to the power 1. Anything to the power 1 is 1. So 9 to the power 3 to the power 1. So that means 9 to the power 3. And then you just equate the indices. Okay. To the next one. So what you see here is what we are doing. We're trying to solve all kind of problem from indices and search so that you can get a flavor of all the topics that we have done. And there are certain problems which are very relevant for CAT or other Indian entrance exam. So we are trying to see what type of problem that can come, what level of difficulty that can come, and we are trying to pick out those difficulty and also those complex level problems as well as problems which are satisfies the understanding that we had in the previous session on the different type of scenarios of indices and surds. So square root of 1280 and 1260. Okay, so that means this is nothing but square root of root over 1280 and root over 1260. So this is the square root that they have asked for. Okay, now if you do 1280, let's simplify this a little more. 1280 if I do by 10, I'll get 128. 128 is nothing but 2 to the power 7. Okay, so okay, so I can further do that. So I will do with 4. So that means that becomes, and that becomes what? That becomes 32. Again, I will do with 4. That becomes 8. Okay, and I will do with 4. That becomes 2. So that means okay. So what is there is 1280 and then there is 1260. So we have to, one way of doing this is to simplify them like this and do that. But the challenge in that of simplifying this is what I understand is from 1260 we won't get the similar number. So that way it becomes a little problem. So let's try to figure out what is common between typically 1280 and 1260. So if I do an HCF of 1260 and 1280 and get the HCF as 5. 5 is the maximum common number between these two. Okay. So what I'll do is I'll take this becomes 5 into 256, right? And this becomes 5 into, if you do 2, so 5 to the 10, 2, 6, 25, 252, right? Yeah. So this becomes 252. So this two you got. Now what we have to do? We have to take out root 5 completely. So then it becomes root over of 256 minus root over of 252, right? So if I take the root 5 completely out of this, this is 5 to the power 1 by 4, because root 5 means 5 to the power half, and then there is another half which is for the bigger, the final root. That means 5 to the power 1 by 4. Then we have a root over of 256 means 16. 16 square is 256. So 16 minus, I can write this as 4 into 63. So 4 into 63. So this can be written as 5 to the power 1 by 4. This is 16 minus 2 root 63. So if you can understand certain things from here, you can see 16 can be written as 9 plus 7 and 63 can be written as 9 into 7. So what we are trying to do is we are trying to make a whole square under this. So 5 to the power 1 by 4. And then 16 can be written as 9 plus 7 minus 2 into root 9 into root 7. That makes it 2 root 63. So then this becomes a 9 minus 7 or 9 squared. So can I write 5 to the power 1 by 4? Then this becomes root 9 minus root 7 whole square, right? So yeah, so from here then we can write this is 5 to the power 1 by 4 into root 9 minus root 7. Obviously root 9 is 3, so 3 minus root 7. So that way you can solve this problem. So the idea is try to take the HCF out and try to make a square root of what is left inside. So the moment we got 16 and the other one is 4 root 63, we got an idea that this can be written as a minus b whole square kind of a thing. Okay. If you have any doubt, please drop a note in the comment section, or you can mail me. We can take from there. Mail ID is again in the description box. So, okay, let's start in the problem. The last one for today. Find the greater one between root 17, root 15, root 15, root 11. So if you recall the last session with the scenarios when the sums are same, which is not same as 17 plus 15 is not same as 15 plus 11. When the differences are same, 17 minus 15 is 4, 15 minus 11 is 4. Sorry, 17 minus 15 is 2, 15 minus 11 is 4. So obviously differences are not same. So all the scenarios that, simplified scenarios that we talk will not be applicable here. So let's see, find the greater one. So obviously let's do a square first, minus root 15 whole square on the one side, and let's do root 15 minus root 11 square on the other side. So this becomes 17 plus 15 minus 2 into 17 and 15. On the other side, this becomes 15 plus 11 minus 2 into 15 into 11. So this is 32 minus 2 root. What is 17 into 15? This is 255. Right? This is 26 minus 2 root. What? 15 into 11 is 165. Now, if you see carefully, 255 is very, very close to 16 square, which is 256. So can I write 32 minus 2 into 16 almost? So because this is 16 square, so this almost becoming 0. It is not 0, but this is very close to 0. Even if it is 15.9, 15.9 into 2 is 31.8. Whereas if I do the other side, it is coming 26 minus 2 into 165 is very close to 13. 13 square is 169. So it is 12.7, 12.8 approx. So can I write this as 12.8, or for the matter of fact, let 12.7 something. So this is not exactly 13, right? So this is lesser than 13. So you will have a comparatively higher value here, because 256 can be approximated to 16 very closely compared to 165 to 169. So there is still a gap. So this number, this gap between 26 and 2 into 12.7 or 8, whatever it is, it will still be more than what you get. So sorry, it will still be more than what you get from here. So this will be somewhere around 0.3, 0.4 kind of a thing. The other way of doing it, if you are getting perplexed here, you are not completely able to see how this term will be more than will be less than this term, or basically why the right one cannot be 0 or little more than 0 compared to what is in the left term. The other way of doing it is you change the sides. So instead of root 17, root 15, let's do for root 17 plus root 11 on the other side, and root 15 plus root 15 on the other side, right? If we do this, let's see what we'll get. If we do a whole square here, what we will get? We will get 17 plus 11 minus 2 into 17 into 11, which is 187. And this is, we get 2 root 15. Sorry, 15 square plus 15 square. We get 15 plus 15 plus 2 root 225. Right? So this is 28 minus 28 minus, sorry, plus 28 plus 2 root 187, 2 root 187, which is close to around 14. So 2 into, or 13.6, something like this. And here we get 30 plus 2 into 15, right? So if you see typically what is happening, so this number is much higher. So if this number is much higher, then can we write root 17 plus root 11, root 17 plus root 11 is lesser than root 15 plus root 15. So if I just change side, I'll be able to write root 17 minus root 15 is lesser than root 15 minus root 11, right? That's what we did earlier. So this number is more than the previous number. Okay. So that's about it. So there are two ways you can solve it, and the second one looks more obvious to you. You can do it that way also. So whatever way you are comfortable, you can solve it. So this is about it for the foundational session. So if you are liking this video, please like, share, subscribe, and feel free to drop a comment if you think something can be changed on the way we are going ahead now. Your feedback will be really helpful. So hope you have a good day, good night, or a good evening. See you in the next time, in the next session. Thank you. Bye.